Happy Tuesday afternoon. You survived the first third of the semester. I think there are only 2 casualties. I lost 2 people. We continue our studies of derivatives. Start with the trigonometric functions. What are the trig functions? How many are there?
6.
What are they?
Sine, cosine, tangent, secant, cosecant, and cotangent.
Derivative sine is cosine. For derivations, just watch the lecture video. Derivative of cosine, negative sine. The idea behind the derivation of these two uses the sum to product. No, the sum identity for sine and cosine, respectively. And remember, the other 4 trig functions can be written in terms of sines and cosines. That's how the derivative of the remaining 4 are found. Derivative of tangent is secant squared. That requires quotient rule. Derivative of cosecant is negative cosecant cotangent. This can be found either quotient rule or chain rule. Derivative of secant is secant tangent. Again, either quotient or chain. Finally, derivative of cotangent is negative cosecant squared, found using quotient rule. Chain rule. The most misapplied derivative rule. Also the one that is also forgotten the most. Chain rule allows us to take the derivative of a composite of functions. The derivative of f of g of x is g prime of x times f prime of g of x. So remember when you're studying composition of functions in pre-calc, and they're emphasizing how to decompose, find f and g such that h is f of g? This is why. Being able to identify your inner function is necessary for chain rule. Chain rule written another way, if you have y as a function of u and u is a function of x, then dy dx is dy du times du dx. When dealing with polynomials, technically speaking, chain rule is never required. Just like product rule would never be required. Because you can always do algebra first and expand it. However, that is not always convenient. Such as, let's say you have a 5th degree polynomial raised to the 50th power, and you're asked to find the derivative. Without chain rule, that's quite the task. With chain rule, it's now a lot easier. Differentiate the function. Identify your inner function first. I'm going to stick with that notation because it's simpler. But the idea is the same. Inner function, what is u?
30x to the 5th plus 6x squared.
I think you skipped ahead. I don't want the derivative, I just want u.
5x is 6 plus 2x cubed.
Now write your function as a function of u. Y equals what? Your derivative would be dy du times du dx. I typically write it in the other order. Right, then that would be g prime times f prime of g. What is du dx?
The derivative of u,
What is it?
30 x to the fifth plus 6x squared.
Now, what is dy du?
40 negative 30.
Replace u with what you said it was.
5x to the 6th plus 2x to the 3rd.
There's your derivative. It actually can be simplified further, can it? If we so choose. Can also factor out 6. And so either one. And there's no need to expand that. Again, you technically don't have to use chain rule here. You could expand that out to the 4th power. And then just use combination of sum difference, constant multiple, and power. That's too much work. Here, on the other hand, chain rule is required. You cannot simplify the cube root of x squared minus 1. You could theoretically write it as a product. Cube root of x plus 1, cube root of x minus 1. That would still require chain rule. First, let's make life easy. Write it as a power. So x squared minus 1 to the negative 1/3. And again, you want to identify what your u is.
X squared minus 1.
Now, write your function as a function of u.
Do the negative 1/3.
So, this is a common practice as well, not just with chain rule, but I think I did it with limits as well, called change of variable. That will come up again at the end of the semester. F prime du dx times dy du. So be careful. While it's convenient to think of this as when you multiply those two together, the du's cancel out, and you'd be left with dy dx. That's not what is actually happening. They're not fractions. They're operators. It is, again, not the only time that that's going to occur. What is du dx? What is dy du?
Negative 1/3 u to the negative 4/5.
So what about 4? That would be the derivative. Trying to write it back in the original form. I'll give you that. Of course, there is no simplification that can be made there, right? That's already fully simplified. Something went terribly wrong here. That's better. Yes, let me actually hide that for right now. To fix that on my master slides. If I bring this up, yep, that should stay up there. Right? Again, technically, we don't have to use product or chain rule here. We could completely expand that out. Again, that's going to be a little tedious. So here's what we're going to want to do. You first look at the function. It's not a composite function. It's a product, which tells you you're going to be using product rule. Now, each component for product rule is a composite function. So let's look at, let's call it u sub 1 for the first function. U is going to be what?
Squared plus 1.
Write it as a function of u1.
U to the third.
Second function, what's u?
X squared plus 2.
Write it as a function of u.
U to the sixth.
Product rule. What did the product rule say?
F of X times G prime of X plus G of X times F of X.
Yeah, I'm going to stick with the other order, but it doesn't matter, it's the same. G of X, there's your first, times, now the derivative of that first function, which will be du1 dx times dy1 du1. Plus x squared plus 1 cubed times the derivative of the second function. du1 dx. To x. Then dy1 du1, 3u1 squared. du2 dx also happens to be 2x, which is nice. dy2 du2. Six u2 to the fifth power. Simplify. Now, typically what we do here is we will factor it. So go term by term. GCF of 6 and 12. Man, this one's easy.
6.
6. This one might be a little difficult. GCF of x and x. So it's the greatest common factor of x and x. X. Greatest common factor of x squared plus 1 squared and x squared plus 1 cubed. Greatest common factor, x squared plus 2 to the 6th and x squared plus 2 to the 5th. Now, what are we left with? An x squared plus 2 from the first term, right? And an x squared plus 1 from the second term. No. Two times x squared plus 1. X squared plus 4. Again, or if you wanted to, you could write it so that the powers are in ascending order. So you could write that way as well. Doesn't matter. What kind of function are we dealing with? And so the dominant rule here is product. What happens when you go to apply the product rule? Times now the derivative of the first function. So now look at that first function. What kind of function is it? which is more broadly known as what kind of function? Exponential is different. It's a power function. It's being raised to a power, so it's a power function. It's actually a composition, though, isn't it? So I don't always write out what the U is. What is being raised to the power? What is its derivative? It's just one. Now, what's the power? What's the derivative of a power? Bring the power down, then subtract 1. This is known as the general power rule. Now product rule says we have to add. Times the derivative of the second function. Again, what kind of function is that? It's a composite. So look at what's being raised to the power. What is its derivative?
3 times 2t squared.
Go piece by piece right now. What is the derivative of the inside function?
4t.
And then apply the power rule.
Times 3 times 2t squared minus 1.
Squared. This is how the chain rule works. Generally speaking, always start with the larger function and work your way in. Two-thirds and 12. So look at it in two pieces. What do we factor out from 2 and 12? 2. But then we also want to factor out the greatest common divisor, 1/3. So we're going to factor out a 2/3. T plus 1 to the lowest power. 2t squared minus 1 to the lowest power. And then t to the lowest power, which is just 0. First term we leave is the 2t squared plus 1. Plus factor of 2/3 out of 12. 12 divided by 2 is 6, times 3 is 18. What are you left with? 18t times what? Now we factored out a negative 1/3 power, right? So that means you're going to add a 1/3 power to that. So just t plus 1. Start with the numerator. Two t squared and 18t, or 18t squared rather, is 20t squared. Plus 18t minus 1. All over 3 times t plus 1 to the 1/3 power. Original problem gave it to us in power form instead of radical, so like that. I will. Skip that one for now. This one. Look big picture. What kind of function are we dealing with? Not big enough. Power. Power rule. Eight times the function. To the 8 minus 1. Now go in. What kind of function is it now?
Quotient.
Now it's a quotient, so now we have to use quotient rule. Again, the only person who's excited about quotient rule. What does quotient rule say?
F of x times f prime of x minus f of x times g prime of x all over g of x squared.
What is f prime?
3u squared.
What is G prime? Oh, that's nice. What is G squared?
E to the third plus 1 squared.
Simplify. So 3u squared common in the numerator. Times that by 8. What are we left in the numerator? U cubed minus u cubed, and then 1 minus negative 1. Two. Oh, that's nice. That can still be simplified, though. Get a 48u squared times u cubed minus 1 to the 7th power in the numerator. All over u cubed plus 1 to the 9th power, right? There's the derivative. Again, the idea is to always write your solution function in the simplest way possible. So what is easier? Taking the derivative of this or taking the derivative of this? And that's the way I want to write it. So this one's going to be a little bit different. Big picture. What rule?
Quotient rule.
Quotient rule. Now I have to take the derivative of the numerator. What kind of function is it?
It's a power.
All right, do that first. Look at the inside.
So it's 2.
It has a non-unitary derivative, so we have to multiply by it. Times 2r. That was just the first piece. Minus. Now we want the derivative of the denominator. What kind of function are we dealing with? Power rule. But does that function have a derivative? What we're taking the power of. It does. What is its derivative?
2.
So multiply by 2. And then the final piece. Square the denominator. Time for some algebra. Factor the numerator. 2 factors out. R squared minus 1 squared factors out. 2r plus 1 to the 4th factors out. Left with 3r times 2r plus 1 minus 5 times r squared minus 1. Times r squared minus 1. 6r squared minus 5r squared is r squared. Plus 3r then minus 5. Not minus 5, plus 5. Over 2r plus 1 to the 6th. Yeah, and I do not believe that r squared plus 3r plus 5 can factor. So there's the derivative. So now we're getting more and more steps into the derivative. Again, that is still a lot better than trying to plug that into the limit definition, isn't it?
I have a question. So the general power rule looks a lot like the power rule shortcut you showed us earlier. So I'm curious as to why that doesn't give us the derivative of that whole statement. Why we have to then go and get the derivative of the thing inside.
Because that is general power rule. General power rule says then multiply by the derivative of u.
Okay, so it doesn't actually affect the stuff inside.
No.
Okay, so
Like the function itself stays the same, right? So u is a function of x. So it is n u to the n minus 1. U remains unchanged.
Right.
Then you multiply by its derivative.
And so now I get why we're doing all that other stuff.
Right? That's chain rule.
Right.
trig. So again, look big picture. What kind of function? So we have to use the power rule. Three times the function squared times what's inside, which is a sum rule. It's the sum of functions. So it's the sum of the derivatives. Derivative of sine was cosine. What is the derivative of cosine? That's your derivative. Actually, that is not as simple as it could be. Where did the negative come factored out? You have no idea what I'm talking about. I have no idea what you're talking about.
Are you saying cosine theta minus sine theta is one? If that sounds familiar.
Cosine minus sine is not 1.
Sine minus cosine.
That's also not 1.
I also just said cosine minus cosine, but that's 0.
You can write that. So glad you asked.
I found some trig identities that can be rearranged.
Expand out sine plus cosine all squared. Sine squared plus 2 sine cosine plus cosine squared, right? What is sine squared plus cosine squared? That's 1. That leaves you with 2 sine, I actually forgot. I forgot the 1. Two sine cosine. double angle identity for sine. That's sine of 2 theta. So then from there it goes to there. Which is a little bit nicer. Took us 5 weeks to really start to delve into trig. Here we are.
I'll take it. Take it.
Kind of function are we dealing with?
Trigonometric
Which one?
cos,
What's the derivative of cosine?
negative sine,
What are we taking the cosine of?
3,
Just 3.
3x,
What is its derivative?
3.
So there's the derivative. Kind of function.
Trigonometric.
Which one?
And
What is its derivative?
cos, or cosine.
Secant squared.
What are we taking the tangent of?
It's 5x.
What is its derivative?
5.
Five secant squared of 5x is the derivative. What's the function?
Trigonometric.
Which one? What is the derivative of tangent?
Secant squared.
What did we take the tangent of?
Theta squared plus 4 theta.
What is its derivative?
That would be 2 theta plus 4.
Just for fun, let's go back to here and let's take the second derivative. Why not? First, what kind of function are we dealing with?
That's the secant.
Think bigger. Think bigger.
Like this, multiplying the secant to the power times 5.
It's a scalar multiple.
What does that mean?
number times a function. 5 is a scalar.
Oh, okay.
Now you go, okay, what did you multiply by? What is that function? What kind of function?
That's power.
So power rule. But what was raised to a power? What is the derivative of secant? And what were we taking the secant of? What is its derivative? There's the second derivative. And then you could take the third derivative.
We can, or that's
We
not
can.
a question for us to do.
Which would be a product. But we won't do it. Yeah. Kind of function.
Sine function.
What is the derivative of a sine? What were we taking the sine of?
E to the fifth plus 1 over 2.
Take its derivative.
5t to the fourth. And I'm going to let someone else buzz in here.
Negative 1 over t squared. Or, yeah.
They didn't write it as a single fraction, so I'm not going to. So I'll leave it like that. So here's a fun little assignment. Now, challenge yourself. So the 7th homework, that is on all of the differentiation rules we looked at before the exam. That is due the 10th. There was a third discussion. Initial posts are due the 10th. Replies will be due the 14th. Replies are not to be posted until after initial posts are due. And the second project is available. That will be due on the 22nd. Once again, to find out your group, just go into Canvas, People, Project 2 Groups. We will continue on Thursday.